Good morning, children. Today we shall study about inverse trigonometric functions. That is chapter 2 of our NCERT book. The inverse trigonometric functions play an important role in calculus, for they serve to define many integrals. The concepts of inverse trigonometric functions is also used in science and engineering. Let me explain the basics of inverse trigonometric functions. Suppose if we write sine theta equals to x, then theta equals to sine will shift here, it will be sine inverse x. Another example, if we write y equals to tan inverse x, so we can say tan y equals to x. Third example, suppose if sine inverse x equals to pi by 6. So x equals to, we can write sine pi by 6, which implies that x equals to sine pi by 6 is 1 upon 2. Sine inverse x should not be confused with sine x whole inverse. In fact, sine x whole inverse equals to 1 upon sine x. And similarly for other trigonometric functions. Now there is a table given on page number 40. The following table gives the inverse trigonometric function principal value branches along with their domains and ranges. Now you can see sine inverse. For sine inverse, domain is -1 to 1 and range is minus pi by 2 to plus pi by 2, and its closed interval. Closed interval means minus pi by 2 and pi by 2 will be included in the range of sine inverse. Similarly, you can see in tan inverse here, domain is real numbers. Range is again minus pi by 2 to plus pi by 2. But here the interval is open interval. So minus pi by 2 and plus pi by 2 is not included. So you have to learn this table. Let us start the first exercise of inverse trigonometric functions, which is exercise number 2.1. So question number 1 to question number 10. Find the principal values of the following. So first question is, we have to find the principal values of sine inverse minus 1 by 2. So we can write sine inverse as it is, and in place of 1 by 2 we can write sine. You know the value of sine 30 is 1 by 2. So we can write sine minus pi by 6, because minus sign is here, so that's why we have to write sine minus pi by 6. Now sine inverse and sine will be eliminating each other. So answer is minus pi by 6. Now you have to look that this belongs to the range of sine inverse minus pi by 2 to pi by 2 closed interval. So minus pi by 6 will be the principal value of sine inverse minus 1 by 2. Let us take another question, which is question number 4. Tan inverse minus root 3. Now again tan inverse as it is. Now root 3 is the value of tan 60. So we can write tan minus pi by 3. Now tan inverse and tan will eliminate each other. So minus pi by 3. Now you have to check. This belongs to, you can see in the table that it belongs to the range of tan inverse, which is minus pi by 2 to plus pi by 2 open interval. Now next is question number 5, which is cos inverse minus 1 by 2. So we can write cos inverse as it is, and 1 by 2 is the value of cos 60. So in place of minus 1 by 2 we can write cos, minus sign is there, so minus pi by 3, which is equals to minus pi by 3. But here minus pi by 3 does not belongs to the range of cos inverse, which is 0 to pi. So this is not the correct answer. So what we will do? We will subtract pi by 3 from pi, the upper limit. So pi minus pi by 3, which is equals to 2 pi by 3, which belongs to 0 to pi, the range of cos inverse. Now question number 9, cos inverse minus 1 upon root 2. So cos inverse as it is. Now 1 by root 2 is the value of cos 45 degree. So we will write cos minus pi by 4. So minus pi by 4 is the answer, but this does not belongs to the range of cos inverse, which is 0 to pi. Again we will subtract pi by 4 from pi, so we will get 3 pi by 4, which belongs to the range of cos inverse 0 to pi closed interval. Now question number 11 to question number 14, we have to find the values. Again the method is same. Now we will take this question as in two parts. First we will solve cos inverse 1 by 2. So cos inverse in place of 1 by 2 we can write cos pi by 3, which is equals to pi by 3, and this belongs to range of cos inverse, that is 0 to pi. So answer of first half is pi by 3. Now second half plus 2 we will write as it is sine inverse. Now 1 by 2 is the value of sine pi by 6. So plus 2 as it is pi by 6, which belongs to the range of sine inverse, that is minus pi by 2 to plus pi by 2 in the closed interval. So plus 2 into pi by 6, which is equals to pi by 3 plus pi by 3, cancel out. So final answer will be 2 pi by 3. So similarly you can do question number 11, 13 and 14 also. So today's homework is you have to complete exercise 2.1 in your fair notebook. Thank you.